I am Teacher Jane and welcome to Physical Science class. We do believe in science that somewhere something is waiting to be known. At the end of this lesson, you will be able to explain the effects of intermolecular forces on the properties of substances. But before we proceed to our discussion, just make sure that you have your pen and paper ready so that you can write what you will learn today. Together, let's explore the world of intermolecular forces.
Now, let's have a recap on what we have discussed yesterday. Using the following questions, write true if the statement is true and write false if the statement is false. You only have 5 seconds to answer these questions. Number 1. There are 3 types of intermolecular forces. True or false? Number 2. The strongest intermolecular forces is called ion-ion interaction. True or false? Number 3. Fritz-London discovered the intermolecular forces. True or false?
Our topic yesterday, intermolecular forces are forces that forms between atoms, molecules, or ions. There are 4 types of intermolecular forces: the ion-ion interaction, the dipole-dipole interaction, hydrogen bond, and the London dispersion forces. Johannes Diederik van der Waals is the one that discovered the intermolecular forces. Have you answered it correctly? Did you get it right? Perfect! Now, let's watch a short video clip of experiment and you have to observe it carefully. Let's roll VTR.
For this experiment, you'll need a bowl, water, liquid dishwasher gel, and some grounded black pepper. Procedure. First, take the bowl and fill it with water. Next, sprinkle some pepper over the water. Then dip your finger into the water and observe. Nothing will happen to the pepper present in the bowl. Now, put some liquid dishwasher gel on your finger and dip that finger into the bowl. You'll notice that the pepper, which is sprinkled over the water, moves away from the finger and rushes back to the outer edge of the bowl.
For the explanation, the pepper floats at the top of the water because of high water surface tension. The water molecules are strongly attracted together. When we add a little soap or a liquid detergent, we break down the surface tension. That is why the top layer of the water molecules quickly spread out and carry out the pepper with them. So what is a surface tension? Surface tension is a phenomenon caused by a cohesive forces or the intermolecular forces between molecules allowing liquids to create a thin film on its surface. So, have you seen some animals that can actually walk through the water? Yes, there are animals that can walk through the water. For example, in this video, it is an example of the water striders. It is actually swimming, running, walking at the top of the water because of the surface tension. Now, let's proceed to the formations of meniscus. There are 2 types of meniscus, the concave meniscus and the convex meniscus. First, let's discuss the concave meniscus. Concave meniscus occurs when there is a stronger adhesive forces between the container and the liquid than the liquid's molecule. It means that from the word adhesive forces or adhesion, it is the strong interaction between different materials touching each other. For example, if we pour some water in a test tube, water is more attractive to the test tube than the water itself because test tube has a polar molecules, and it is also because of the hydrogen bonding. Now, let's proceed to the next type of meniscus, that is the convex meniscus. Convex meniscus occurs when there is a stronger cohesive force between the liquid's molecule than the adhesive force between the liquid and the container. It means that convex meniscus occurs when there is a stronger interaction between same materials than the interaction of different materials. For example, when we pour some mercury or alcohol in a test tube, it forms a convex shape because of the interaction inside the test tube. Now that we are done discussing the two types of meniscus, let's proceed to viscosity. Viscosity is the resistance of a liquid to flow. The more viscous a liquid is, the thicker its consistency. In layman's term, it is the measure of the thickness of a liquid. In general term, stronger intermolecular forces leads to the higher viscosity. Now, let's watch another video on how to measure the viscosity of a liquid. Please observe carefully. As you observe in the video, the liquid with the longest time is the most viscous, while the one with the shortest time is the least viscous. The most viscous liquid has the stronger intermolecular force, and the least viscous liquid has the weakest intermolecular force. Now that you know on how to measure the viscosity of a liquid, let's proceed to capillary action. A capillary action is a phenomenon wherein a liquid is able to rise up on a narrow tube. For further explanation of capillary action, let's have an example. When you dip a narrow glass tube in water, water moves up to the length of the tube to a certain extent. This occurs because of the attraction between water molecules and the molecules of the inner wall of the tube, as pulling the water upwards. Similarly, in plants and trees, xylem vessels that is present in plants helps transport water from roots to the leaves. Now that we are done discussing capillary action, let's proceed to the last properties of substances, that is evaporation. We all know since elementary what is evaporation. Evaporation is a process of turning liquid into gaseous form. Now that we are done learning the effects of intermolecular forces on the properties of substances, we have to apply one of the properties by doing an experiment. This experiment is called floating paper clips. By doing this experiment, you can be with yourself or you can be with your family. The needed materials are paper clips, water, and a clear glass of water. Procedure: fill the glass of water. Make sure that it is full. Answer the questions given. Question number 1. What will happen to the paper clips when you put it carefully to the water? Question number 2. How many paper clips will you put to overflow the water in the glass? And the last question. What kind of properties of substances that is used to this experiment?
Congratulations! You are done exploring the world of intermolecular forces. Now you are ready to the next lesson. For any clarifications or questions, just PM me. Once again, I am Regina Jane Hagmok, your physical science teacher.